Hope you all are fit and fine. You are doing very well. Today, we are going to learn a very important reaction of organic chemistry. Generally, you can consider it from the chapter of aldehyde and ketone, that is the chemistry of carbonyl compounds. And this reaction mechanism, or should I say reaction mechanisms, will actually show you how different organic reactions are somehow interrelated. This reaction basically known as, the first one is the MPV reduction, Meerwein-Punnder-Verley reduction, and this one illustrates how you can reduce, especially if I consider a ketone, into the corresponding secondary alcohol. We all know that when the ketone undergoes a reduction, it gives you the secondary alcohol. The next reaction mechanism, which will be somehow related to this, and you will be able to figure it out once you go through the whole video, and that reaction is known as open air oxidation. So if I say something is opposite to the reduction, so that means it is going to be the oxidation in its own way. The methods of the oxidation can be different, as we know. Similarly, the methods for the reductions can be different, as we can see in different reactions, but most of the cases it deals with with the hydride transfer. Correct. So hydride transfer is one of the key facts that we will learn in this mechanism. Let's start the mechanism and let's see how this reaction is going to take place. Okay, so the reduction is basically known as the MPV reduction, that is Meerwein-Punnder-Verley reduction. Okay, you just can go through the thumbnail and you can get the full form of MPV reduction. So what we are supposed to do in this MPV reduction? So we are going to take a ketone. As I told you that we are going to take a ketone. Generally, we are using the reagent which is aluminium isopropoxide. Clear? Aluminium isopropoxide. Me2CHOH is the isopropyl alcohol. From there we get the aluminium isopropoxide. It will establish an equilibrium, and we need the medium as in the form of isopropyl alcohol. What we are expecting first, it will give you have Me2 here, you have R2 here. Just think about it. What we will do, we will just replace this. So it will be R2CHO whole 3Al. So naturally, where this Me2 will be gone, and that is going to give you the Me2CO. And after this, if you give it dilute H2SO4, so you can consider it as an acidic hydrolysis, it will give you R2CHOH, 3 moles obviously here, plus Al3 plus. What is the Al3 plus? It can be in the form of the aluminium salt. It is basically here is the aluminium hydroxide. Clear? So now this is the secondary alcohol, right? 2 degree alcohol. Clear? It is the 2 degree alcohol. So the ketone gets converted to the 2 degree alcohol. The ketone is getting converted to 2 degree alcohol. So what we can simply represent it as, this R2CO will be converted to R2CH. Think about it. So what we call this reduction? So this is MPV reduction. So I am giving you time. You first take it on your copy, that basically how we are representing this MPV reduction, and obviously now our turn will be how this reduction is taking place. Actually, the basic thing is that you have a ketone, you are allowing this to react with the Me2CHO whole 3Al is the aluminium isopropoxide. It will give you R2CHO whole 3Al. Just try to remember in this way that we are going to replace the Me, means it is an exchange kind of thing, right? So it is giving you R2CHO whole 3Al plus Me2CO. Me2CO is what? Obviously propanone or acetone as you say. And now if you hydrolyze this in the presence of acid, generally we prefer to use dilute H2SO4 here. It is giving you the R2CH, that is the 2-degree alcohol, right? And the aluminium ion, that is basically it will give you aluminium hydroxide. Well, so next the target is to understand how this reaction is being carried out, correct? So hopefully you have understood the basics of the reaction, and now we are going to understand the mechanism of this reaction. So what we are having here, understand, you have R2CO, think about it, you have R2CO, correct? What you are using as a reagent, aluminium isopropoxide. Can you write it in this way? Al this side, OCH, Me2, OCH, Me2, OCH, Me2. Okay, the style of writing is in this way because it will help you to understand how the reaction is proceeding, correct? So you understand that this aluminium in its own way, it is electron deficient. I am saying in its own way. What does it mean? It means that this aluminium is always trying to accept the electron because octet is not filled up, right? So basically this lone pair is being donated towards aluminium, correct? Once, think about it, once this aluminium is trying to snatch the lone pair of the oxygen, so this oxygen is getting positive charge, right? When this is getting a positive charge, so it is trying to withdraw this towards itself. That is creating a positive charge on the carbon. So now carbon is becoming electron deficient and it is in the search of the electron pair. Where from it can get it? It can get it from this hydrogen, that is, think about it, it's not the hydrogen only, it's not the H plus even, it's the H with the 2 electrons, that means it is the H minus. So here is the main game, here is the main part, here is the main fact which you have to understand, that this hydride is being transferred towards this carbon, which is in turn becoming, which is actually becoming electron deficient due to the withdrawal of this pi electron pair towards oxygen, and that is actually created by the coordination between this oxygen and this aluminium due to the Lewis acidity of the aluminium. Think about it, pause the video, try to understand the first part of it, okay? Have any doubt, you can comment down. Well, so if this is the scenario, now if this one is going toward this, so how come this carbon is going to be satisfied? How come this carbon is going to be satisfied? Obviously now this will withdraw this. Clear? So aluminium is making a new relation with this oxygen, so its earlier relation is going to be broken up, right? Something practical, isn't it? So what is happening here? Think about it. You first make it yourself. You first this the full diagram is in there, the full plotting is there. You just can write down and you can think that what you are going to make here. So basically, if we don't want to waste the time, we understand that what is happening here, this bond is being broken actually. That is going to make a coordinate bond with the aluminium, correct? The C is going to make the bond with the hydrogen. This bond is going to be broken with the carbon. Nothing to happen with this Me. This carbon and this oxygen, they are making a new relationship, correct? This oxygen and this aluminium is going to be broken. This side we have OCH, Me2, OCH, Me2, correct? Can you think about it? So think about it, this C and this H, they are making a new bond. This carbon and this oxygen bond is being broken. This oxygen, this aluminium bond is being formed. This is the formation sign here. This aluminium, this oxygen sign bond is being broken. This oxygen and this carbon making a double bond is in progress. Rest of the part is as it is. Think about it. This is what? This is a six-membered. This is a six-membered cyclic transition state. So there can be a homework for all of you. What is the rate determining step you are expecting? Have we done the rate determining step so far? If yes, then you can comment down which one is the RDS or which one is the rate determining step here. So this is a six-membered cyclic transition step, stable one, and that is actually the driving force for the reaction. Clear? So hopefully you have understood so far, and now let us proceed that this reaction is now going to be completed, right? So now the bond breaking and the bond formation, everything will be done, and what you are supposed to get here is R2. Think about it, R2 CH. Now look, this hydrogen from here has actually come to this carbon of the ketone that we selected at the beginning. So R2 CHO, correct, R2 CHO aluminium, and this aluminium is now with OCH Me2, right, plus what are we getting? We are getting MECO. That is, we have already got this one. That is the propanol. So propanol 1 mole we have already got, correct, plus this one. Now next what? If you understand that we started the reaction with R2CO and we have come down to this. By 1 mole of R2CO, we have actually replaced 1 Me2CHO by this R2CHO. So think about it. If we have another 2 moles to react, if we have another 2 moles to react, 2 moles of R2CO, what will happen? The rest of this 2 will also be gone. That means it will now give you AlOCH R2. So same mechanism will be followed. OCH R2, and obviously this is R2CH. Correct? The last part is very easy, and I am not going to show this mechanism. This is the H3O plus. However, I will give you a hint of it. So H3O plus, it will be converted to R2CHOH plus Al3 plus. As I told you, this is basically AlOH whole 3. If you ask me how this is happening, very simple. This water, oxygen can also give the lone pair. So again, see, after all of this, even after all of this, this aluminium is not going to be satisfied. That means the aluminium is not having the octet surrounding this. So what is happening? This lone pair is going to attack on the aluminium. It will coordinate with this, and finally you will get all the bonds broken, and that will be converted to R2CHOH. Along with that, you will get Al3 plus. So what we have got? We have got R2CHOH. This is simply an hydrolysis mechanism. You can check my different videos where I have discussed about the hydrolysis mechanism. So think about it and let me know in the comment box if you understood this mechanism, how from R2CO we are getting R2CHOH. Okay. Now this MPV reduction, why we are doing this MPV reduction? Do we have any synthetic use of it? Synthetic use in the sense, do we have any practical use of it? Yes, we have. Suppose for an example, you have something like this, right? And you want to convert it to this one. Think about it. Just write down the reaction at first. Just write down the reaction at first. What are you going to use here? Think about it that this one should be such that will not hamper the double bond. Clear? Yes, you can use MPV here. For this particular reaction, the yield will be 70%. Successful reaction, obviously. Similarly, suppose if I have another reducible group, something like this, Me2CO CH2NO2. Think about it. You want to convert it to Me2CHOH CH2NO2. Again, what will you use here? Yes, undoubtedly this will be again the MPV reduction. This NO2 not going to be hampered. So write down that if you have the different reducible groups, even after that this MPV is not going to harm that. That means it is only concentrated on this. Correct? So this is the synthetic use of this MPV reduction. Now the question is that, sir, what is the another reaction that you told which will be used here? So just opposite of this is open-air oxidation. Just opposite of this, opposite of MPV reduction is the open-air oxidation. Obviously reduction, so oxidation. What is happening here in this particular reaction? What we are supposed to get? So think about it. What is the opposite term of this? The opposite term of this, you will have an alcohol, secondary alcohol. So like you have R2CHOH, correct? You will convert it to R2CO. Think about it. Just first understand the basic outline. The outline is the 2-degree alcohol will be converted to the ketone. Yes. What are you going to use here? We can use here aluminium isopropoxide, even, or we can even use here aluminium tertiary butoxide. Both can be used. We generally prefer the first one. So aluminium isopropoxide. Okay. So let us write down the basic scenario, how this is going to take place, the open-air oxidation. So you have R2CHOH, correct? R2CH is what? It is the 2-degree alcohol. We want to convert it to the ketone, so oxidation has to be taken care of. And what you have here? You have here Me2CHO whole 3A. Your first job is to understand how to proceed with this reaction. This is aluminium isopropoxide. If I simply allow them to react, then what is supposed to be the product? Think about it. What is supposed to be the product? So the reaction will be same as the earlier one. You see, there will be an exchange between this. What will happen? There will be an exchange between this. That is, this R2CH, this R2 group will take the position of the Me. But think about it, we have taken here only 1 mole of this. So take some time and tell me what will be the product. So tell me in the sense you can just check yourself that whether you are understanding what will be the product in this first case. Okay. So make this, take some time, make this, giving you some time. Clear? So what is supposed to be here? Just replace one of this by this group. So R2CHO. Think about it. R2CHOAL OCH Me2 whole 2. That means one of this has been replaced by this group. So where that one is going? Where that one is going? That one is being converted to Me2CHOH. That one is going to be converted to Me2CHOH. Think about it. How actually we are doing this? We have OCH Me2. We have OCH Me2. And we have OCH Me2. Right? Clear? If you allow this R2CHOH to react with this, R2CHOH to react with this. So basically, this lone pair will attack here. So can I make this on spot that if this lone pair is attacking here, so this oxygen is giving a plus CH R2, right? This is clear. So this oxygen is generating a positive charge. This one is withdrawing this part, this hydrogen. This hydrogen now is going to be trapped by this oxygen. So now this hydrogen is released from here, but it is now going to make a bond with this hydrogen and thus generating a positive charge. This aluminium is already having a positive charge because this lone pair was donated to, this is having a negative charge because this lone pair was donated to aluminium. Now what? This will be taken out. So it is going Me2CHOH. So Me2CHOH plus Al OCH Me2, both side, and this side is R2OCH R2, that is R2CHO. Simple. Just understand it is a kind of exchange. You are exchanging this with this, right? So just write down this mechanism, giving you some time, telling the mechanism again. This was actually having R2CHOH. You can just rewind the video and you can just check. This oxygen lone pair was donated to this aluminium, that is getting a negative charge, this is getting a positive charge. To satisfy itself, this hydrogen was taken out, this H plus now attacked here. So now this is protonated. So this is going to be satisfied by the withdrawal of the electron pair with the aluminium, thus also creating a positive charge on the aluminium, but already it is having a negative charge. So the negative positive will cancel and this will be as simple as that, a neutral species. But think about it, this is still not satisfied. That means this is still the Lewis acid in its own way. Now, next what? We use here in this reaction excess of acetone. What we use here? Excess of acetone. Now see the similarity. This similarity is there because open air oxidation is just the reverse of the MPV reduction. Obviously oxidation is reverse part of the reduction, but what is the similarity, how the reaction is proceeding? Think about it. We have used the acetone here, that is Me2CO, going to react with this species, the species that we have already produced, correct? So what we are having? Al OCH Me2 OCH Me2. My work will be with this O. Let me just remove this part. Hopefully you have copied it. O CHR2. Don't you think that this is the way we just have written the MPV reduction mechanism also, the similar kind of way, right? Just think on this. So this is the Me2CO. We take excess of Me2CO to drive the reaction in the forward direction. Correct? To drive the reaction in the forward direction. So what will happen? Again, this is the lone pair. It will be donated towards what? Obviously aluminium. So again this carbon will be getting a positive charge because of the withdrawal of this. So this will come here and this will come here. Okay, I don't want to waste the time and I don't want to elongate the video. So you can find it out that what is the product you are getting. You are getting Me2CHO connected with aluminium. I'm not writing the next part. The most important thing, when this comes here, you are getting RCOR. What is that, my dear? That is the ketone. You started with what? You started with R2CHOH. What was that? The 2 degree alcohol. Correct. The 2 degree alcohol is getting converted to the ketone. So isn't it just the opposite of the MPV reduction? Okay. So hopefully there are so minute things, in every step. Okay, you have to understand that in each and every step, you first have to understand why each and every step is taking place. Once you can figure it out, you can decipher that you are actually getting the essence of organic reaction mechanism. And once you understand the organic reaction mechanism, any problem, just solving that one is a cakewalk. Clear? It's a cakewalk. So basically, your first part is to understand how the organic reaction mechanisms are taking place. Why? Each and every step, why it is taking place. Once you can understand that, rest of the part is very simple. Okay. So thank you. I hope you have understood this. If you have any doubt, you can comment below, okay, in the comment box. I will try to solve the query that you are having. Obviously, if it is possible at that particular space, if it is possible, or if it is not possible in that way, I will try to make another video with specific doubts of yours. Okay, thank you everybody. Stay well.